Question 11, and we're presented with a relatively straightforward integration question. We've got a curve C, here's the equation, and we've got to work out the area under that curve from the limits of 0 to 1. So the whole thing rests on being able to integrate this. We've got an x squared, we've got an e to the minus 3x. This is going to involve integration by parts. Now, integration by parts uses this formula and relies on the fact that we can make the second integral simpler by a wise choice of u. So my two substitutions I'm going to use is that u is equal to 8x squared, and therefore dv will equal e to the minus 3x. And because we're going to have to go around this loop twice, I'm going to use a table form to create the calculations. If you've not seen this before, this is a really good way of working out this integral, which I say we'd have to go round twice. And I'm preparing 3 columns effectively. This is the sign, this is a column for u, and this is a column for dv, and this is a column for results. This column always starts off with a plus and will oscillate plus minus, plus minus, plus minus. Here I write down my choice of u, which is 8x squared. And I differentiate until I get to 0, down the column. So differentiating this, I get 16x. Now I get 16, and now I get 0. This column I write down dv, which is e to the minus 3x. And this column I integrate each row. So this is going to be e to the minus 3x multiplied by negative a third. And the next one down, again, e to the minus 3x multiplied now by another third. So this will be positive a ninth. And I'm going to do this one as well. So this is e to the minus 3x multiplied this by minus 1 over 27. That's actually done all the hard work. So just as the formula suggests, our first term will be uv, and that will be this multiplication. So this gives a result of plus 8x squared multiplied by minus a third e to the minus 3x. And the next result will be the red lines joining this group of terms. So this is minus 16x multiplied by a ninth e to the minus 3x. And you won't be surprised to hear that the next result will be the multiplication of the red lines indicated now. The next line we don't have to bother with because there is a 0 involved and we'll get no result. So all we need to now do is add up the results. So our integral will be equal to, well, let's take e to the minus 3x out of it all. This is negative 8 over 3 x squared minus 16x over 9 minus 16 over 27, and of course there will be a plus c. Now our limits were from 0 to 1. We don't have to bother with c because we have limits. So substituting. So this is equal to e to the minus 3 minus 8 over 3 minus 16 over 9 minus 16 over 27. And we take away, well, if I plug 0 into e to the minus 3x, I will get 1. And this multiplies by, this is 0, this is 0, so I just get negative 16 over 27. And I think given all these terms are negative, I can bring the negative outside, and this is e to the minus 3. And if I put this all on a common denominator of 27, I get 136 over 27, and this term will be positive 16 over 27. So comparing with what they're suggesting here, I can say that A is equal to 16 over 27, and B is equal to negative 136 over 27. And of course what we've just found is that the area R is equal to both this and these are the constants involved. And that's the end of question 11.